Here are some more examples of the chain rule working through odd problems of section 3.7 in your book. So number 9 gives us the equation y equals sine to the 6th power of x. I think for some people the exponent of the 6th, the way it's written, might be kind of confusing. You might even want to rewrite this as sine of x all to the 6th power. Then with the chain rule, you focus on the inside and the outside. You always start by taking the derivative of the outside. So in this case, focus on that exponent, the 6th power, being our derivative or our outside. So we're just going to take, and to find the derivative, we're going to multiply that 6 down in front. We're going to leave the middle the same, sine of x, and we lower that power or reduce that power by 1. So that was taking the derivative just of the outside. So take the exponent, multiply it down in front, reduce it by 1. Notice that my middle did not change. Now we have to deal with the middle. So now we're looking just at sine of x. The derivative of sine is cosine x. So we multiply by cosine x. So my derivative is 6 times sine of x, all to the 5th power, times cosine x. Let's try another one. Looking at number 13, y equals cosine to the 4th power of 7x. Again, to more closely see the inside versus the outside, you may want to think about this as cosine of 7x, all to the 4th power. So again, we're focusing on the outside. So we're going to take that exponent, the 4th power, and to find our derivative, we multiply that in front. Leave your inside the same, cosine 7x, reduce your exponent by 1. Okay, now we look at the inside. Our inside is cosine 7x. So first we're just going to focus on the cosine part. The derivative of cosine is negative sine. And we're still going to keep 7x. Here we kind of have an extra inside. So cosine 7x was an inside, but now of our inside, we have another inside because we have 7x. Notice on the previous problem, we just had an x. So now we're going to find the derivative of 7x. The derivative of 7x is 7. I would prefer that you simplify this down. So multiply our constants together. So 7 times 4 is 28. I'd pull out that negative. So negative 28 cosine 7x to the 3rd power times sine 7x. Section 3.7 has you doing the chain rule quite often using trig functions, but we can look at the chain rule, for example, in number 19 where we don't have trig functions. Again, we're just going to focus on the outside. Some people prefer to think about this as just rewriting it. So for example, imagine that this was just a to the negative 6th power. If all you had was a to the negative 6th power, you know that you would find the derivative of that by taking negative 6 times a to the negative 7. Remember, reducing negative 6 gives you an exponent of negative 7. However, what was a? Well, a was this part up here. So really what I have is negative 6 times 4x cubed minus 7 to the negative 7th power. The issue is here I have to look at my inside, because I have to take the derivative of 4x cubed minus 7. And that gets multiplied by this. So if you look at your inside, the derivative of 4x cubed, multiply the 3 down in front, gives you 12x squared. Derivative of 7 is 0, so you could just leave that as is. And again, simplify it down, not that I would count it incorrect if you got it this far. We have negative 72 x squared times 4x cubed minus 7 all to the negative 7th power.